Here we go. Let's solve some polynomial inequalities. We're going to start off with a quadratic, and eventually we'll move up into cubic and then rational inequalities as well. So first thing first, we have to get it in standard form, and we want it to be less than or equal to, greater than or equal to 0. It's a lot easier to see if a function is above or below 0 because we can visually see it by them being above or below the x-axis, or we can just look at the function and see if the y value is going to be positive or negative. So always have 0 on one side. So let's take a look at this example. Get it in standard form first. 0 on one side. We got x squared plus 3x, and then subtracting that 10 over, and that's greater than or equal to 0. Now that we have it in standard form, we can finally move on to our official step 1, which is finding the zeros. So this one factors nicely. We got x plus 5 times x minus 2. And then since I'm finding the zeros, I'm going to set it equal to 0 for right now. That means that x is going to equal 0 at negative 5 and 2. We need to know these values because this is where our function will potentially cross the x-axis, right? At our zeros, we're not positive or negative, we're just 0. So using these values onto step 2, these are what we call critical numbers, and we're going to use them to create test intervals. So I'm going to create a little, it's called a sign chart. It's a little number line, at negative 5 and 2. And I want to choose numbers to determine, to be my tester numbers. So step 3, choose an x value in each interval and evaluate the polynomial's sign chart. So choosing an x value, we want something less than negative 5. So let's say I want to figure out f of negative 6. And then in between 5 and 2, well, the easiest one would be f of 0. And then for 2, let's just do f of 3. Okay, you can choose whatever numbers you want as long as they're within those intervals. We're looking to see if the function ends up being positive or negative. So when I do this, I always look at my factored versions because it's the easiest. I got x plus 5, x minus 2. Well, if I were to plug in a number smaller than 5, negative 6 plus 5, well, that would end up being a negative. Negative 6 minus 2, that's also a negative. A negative times a negative gives us a positive, so we are above the x-axis there. All right, looking at f of 0. F of 0, we got 0 plus 5 is 5, so that's a positive. 0 minus 2 is a negative. All right, so here is where we drop below because a positive times a negative is a negative. F of 3, same idea. 3 plus 5 is 8, so that's positive. 3 minus 2 is 1, so that's also positive. Positive times a positive is a positive. All right, we want to look at these values because if we were to graph this, positive means I'm above the x-axis, we cross down, then we're below, then we're above, right? A graph would look something like this if my sign chart was our x-axis. So we're specifically looking for when x is greater than or equal to 0, that means positive. So the sections that we care about are less than negative 5 and greater than 2. To write this out as our final answer, we're going to want to use interval notation. So our solutions are from negative infinity all the way up until negative 5. I know I want to include negative 5 because of this or equal to. Union, we also have another set of solutions, including 2 going until infinity.